All right, y'all. So 9.2 deals with inverse functions. So we'll start off dealing with relations, which are like ordered pairs and stuff. Then we'll get into what we call a horizontal line test, and then we'll finish it up with our inverse functions. All righty, so the first thing is to find the inverse of a relation. So to find the inverse, of a relation, we simply reverse the X and Y values. Okay, so I'm going to give us an example of this. So for this example, they want us to find the inverse of the relation. Okay, so the relationship they're giving us is a set of ordered pairs. We got -9, 2, -7, 7, -2, 9, and then finally 5, -5. All right, so there's my relationship. My ordered pairs are -9, 2, -7, 7, -2, 9, 5, -5. Now, in MATLAB, they give you the fancy little parentheses. All you got to do is put your answer in there and put commas between each point. And y'all, guess what? All we're doing is reversing the X and Y values. So the first inverse for -9, 2, if I reverse that, I get a 2, -9. And y'all, we'll just continue switching every X and Y value. So we'll get a 7, -7, 9, -2, and then finally a -5, 5. So anytime you have a set of ordered pairs, the inverse is going to be you flipping them values around, okay? So let's try this one and see what we'll do here. This one says, find an equation of the inverse relation. So the equation they're giving me is x to the third y equals a -7. Oops, I'm going to say answer. So basically, an inverse equation, all we're going to do is switch the X and Y. So I'm going to come in and switch the X and Y. Now, when I switch them, I don't move that exponent. I'm going to keep that exponent there. All I'm going to do is switch that X and Y value. So I'm going to get a y to the third x equals -7. So notice the y has taken place where the x was, and the y is now being cubed, and x is being multiplied. So they're letting you do a few problems like that so that you're going to get the hang of what we're going to do when we actually find the inverse of a function. All right, but y'all, before we do that, we need to learn about what we call the horizontal line test. So here's the thing. This horizontal line test it determines if a function is what we call one-to-one. So the function has to be one-to-one for it to have an inverse. So this determines if a function is 1, 2, 1. Now what that means is, remember a function, every x could only have one y value. So to be one-to-one, that means the y values can only have one x value. So there's no repeats on these y values or these x values, okay? So I do the horizontal line test just like I did the vertical line. I'm going to run a horizontal line down my graph to see if it intersects it once or more. To be one-to-one, it can only intersect my horizontal line one time. So if a horizontal line can intersect a graph more than once, the graph is not one-to-one. So it can only intersect your graph one time. So I'm going to do a couple of these to show you what I'm talking about. So let's draw a graph here. So my first graph, I'm going to have a line coming uphill from left to right. All right, y'all, let me let one in real quick. I got a couple coming in. All right, y'all, so here's the thing. If we was to run a horizontal line down this graph, notice it's only intersecting my pin at one place. As I move my pin down, it's only intersecting at one place. No matter where I go on that graph, these horizontal lines are only going to intersect that graph at one place. So since it only intersects the graph at one place, this would be yes, one-to-one. Okay, so all the x values only got one y value. All these y values only have one x value. So horizontal line can only intersect it once to be one-to-one. So y'all, let's try this one. I'm just going to draw a parabola like y'all been graphing. So I got a parabola upside down. But y'all, the question, is that one-to-one?
No.
No, because good job. Because if you do your horizontal lines, you're going to intersect it on this side and that side. So good job. This will definitely be a no. So on that, they'll give y'all a few pictures. I'm gonna do a couple more here. All right, so let me see, where's that? All right, so I had one that went up like this and goes up. Over here, it sort of comes down. And then let's see. The bottom sort of curves up and around for that one. So we'll draw graphs like this when we hit, the third test material. But the question, is this first graph one-to-one?
No.
Good job. And it's got a lot of places where that one's hitting it twice. All right, so let's try one more. How about these cube graphs? The cube graphs comes up, sort of goes through the middle, and then curves on up.
Yes.
So that'd be yes, because when you run it down, it's only intersecting at one time. All righty, y'all. So that's how we determine if they're one-to-one. So you graph these real quick and look at them on your calculator. You can sort of see really quick. But I ain't gonna lie, the problems we're about to do that start with 7 through 12, you're gonna be looking for inverse functions. And the part A, where it asks you if the function's one-to-one, all of these are yes, one-to-one, okay? So I'll just give you a heads up on that. So here we go. Steps to finding the inverse of a function. All right, so you're going to be given f of x equals something to x and whatever. So the first thing we do, we can't solve it while it's got that f of x there. So the first thing we do, we're going to replace the f of x with a y. Because remember, f of x and y are basically the same thing. F of x is just function notation. Y is just variable notation. So I'll replace the f of x with a y. And then if you remember on the first example, where I found the inverse of a relation, what did we do?
Did we flip it?
Flipped the X and Y value.
And that's what I'm going to do here. I'm going to switch the x and y variables. Because in this, they'll actually be variables. So we'll switch the x and y variable. So then what you're going to do, once you switch them variables, you then solve for the y. So solve for y. And I'm going to let another one in. All right, switch the x and y variables, then we solve for the y. Now, since we're finding the inverse function, the last step I do is I'm going to replace the y with f negative 1 of x. This right here is what we call the inverse function notation. So f of x is the function. This f negative 1 of x is the inverse function notation. Now, MATLAB will usually put the f negative 1 of x equals, and all you got to do is put your new function in there, okay? But we don't do nothing with that exponent. That's just notation, letting me know that this is my inverse function. So y'all, let me do some of these. So this will be like y'all's number 7. For these examples, they're going to say for each function, A, we're going to determine if it's one-to-one. B, if it's one-to-one. So if one-to-one, find its inverse. All right, so for y'all's numbers, these start at number 7. So at number 7, they're giving me f of x equals x plus 2. So let me show you. I'm going to go graph that real quick. So let me share my calculator screen. I'm going to go to y equals. And let's see, is that an x? Okay, that's x plus 2, what I needed, right? So let me get rid of that 8. So there's my x plus 2. All I got to do is look at the graph to determine if it's going to be 1-to-1. So y'all, you got a straight line going uphill to the right. Is that 1-to-1?
I have a question.
Yeah.
Yes.
How did you get the X up there? You don't mind me asking?
On the y equals.
Yes.
Do you see the button that says mode? Right under
Yes,
the
sir.
mode button, there's a button that has an X, a T, a circle with a line, and a little N.
Yes, sir. I got it. Thank you.
I hit that one to get my X's real quick. If you don't, you got to use that alphabet button.
Mm-hmm.
And I think the X is above the bottom left. It's by that STO button. But you hit the green button to do that. So I just hit that XTO button and get it done quick.
Okay, thank you.
All right, y'all. So let's look at this graph. Is that graph 1-to-1?
Yes.
Yes.
So it's definitely 1-to-1. So now we're going to find our inverse. So you would tell it yes on A. All right, so to find the inverse, I'm going to do what we said. First thing I'm going to do is replace this f of x with a y. So I'm going to have y equals x plus 2. So I'm going to write the steps out over here. Replace f of x with a y. All right, then we said we're doing what to these x and y's?
Switch them.
Flip them.
So I'm going to switch these around. So switch x and y. So y'all, that'll give me x equals y plus 2. So the equation stays the same. We're just switching them variables. All right, at this point, solve for the y. We got one move on this to solve for that y, which is
Subtract 2 from both sides.
all right, I'm going to subtract 2 from both sides. So I get x minus 2 is equal to my y. And then my final step, I'm going to replace that y with the inverse notation. So I'm going to have f inverse of x is going to equal the x minus 2. And that's it, y'all. So the trick on these problems here is being able to solve your equations once you switch them variables around, okay? All right, y'all, questions on that? All right, so we got about 3 or 4 more of these, and let's try the next one. Let me get my paper flipped over. I must write hard and it curls. So for number 8, they're giving us f of x equals 5x minus 6. So we'll go graph that real quick and see if that one is 1-to-1. All right, so go back to my y equals. I'm going to clear that out. And this was what, 5x minus 6. So I get my 5. I'm going to hit that button up there to get the x, and then plus 6. All right, but I'll tell you our trick. Anytime it's a single x like that, you're going to get a line graph. And this one sort of goes uphill. So the question would be, is it 1-to-1?
Yes.
All right, so that's 1-to-1. And I think basically all of these are going to be 1-to-1 for y'all. So it's 1-to-1, we're going to find the inverse. So first of all, we're going to turn that f of x into a y. So once again, replace f of x with a y. All right, next I'm going to switch that x and y around. So notice the 5 stays, all we're moving is the x. So this will equal x equals 5y minus 6. And y'all at that point, solve for y. And y'all, to solve this one for the y, we really need to get the 5y by itself first. So that -6, to move it, we're going to add 6 to both sides. So notice I now got an x plus 6. That's going to equal to 5y. All right, then to finish that out, that 5y, we divide by 5 to make it a 1y. And y'all, here's the trick. Everything on the left side has to divide by that 5. All right, so good. The right side, the 5's cancel, making that a 1y. So y'all, can we do anything with this x plus 6 over 5?
No.
Nope, so we're going to keep that at x plus 6 over 5. And then remember my last step, put it in an inverse function form. And our answer was what? X plus 6 over 5. But you notice things on these. They were subtracting 6. My inverse was adding 6. They were multiplying by 5. We're dividing by the 5. It's almost like you see a lot of counter moves on these when you do them, okay? All right, y'all got a question on that? All right, so I'm gonna make this one a little trickier. This one's gonna be trickier to actually solve, but I'm gonna have f of x equals 5 divided by x plus 9. So let me show you how I would graph that. I'm gonna go to y equals. Now there's 2 ways you can graph this. I'll show you both ways. The first way is to hit the alpha button, which is green, and then the y equal button. When you hit them together, it brings up n over d, which is fractions. So I'm just going to hit enter on that. If I do that, I can put it in exactly like it looks. I can put my 5 on top, and then I can arrow down to the bottom and put in the x plus 9. All right, y'all, so that's one way you can put this into the calculator. Now I'm going to clear that and show you the other way. The other way is to come in here and do 5 divided by. When you got a fraction with more than one part on top or bottom, you got to put that in parentheses. So then I would put my x plus 9 in parentheses if I don't do it in the fraction format, okay? Because if you don't put it in parentheses, the calculator will do 5 divided by x and then plus 9 to the side. We need that whole x plus 9 to be our denominator. But y'all, no matter which way you do it, when you hit graph. So if you notice, that's sort of like the first one I did. It's a slowly going downhill from left to right. But if you was to do some horizontal lines, you would notice it would not intersect it, but one time each. So yes, that was going to be 1 to 1. So we're going to find the inverse. Same steps. Replace the f of x with the y. All right, replace f of x with the y. Now we're going to switch them like we did there. So this will become a x equals 5 over y plus 9. Here's the trick on this one. All right, let me let another one in. Well, I got them coming in late. Okay, let's see. Here's something. I got to solve for the y, but the first thing I need to do, I need to get this y plus 9 off the bottom of that fraction. I need it up top where I can actually solve for it. So to do that, what you would do is multiply both sides by this y plus 9. And if you notice, the reason I did that on the right side, I can now cancel those y plus 9s. So that's just going to leave me a 5 on the right side. So y'all, what you want to do here, I'll tell you, there's two ways you can do this problem. You can distribute that x through the parentheses, or you can leave it like it looks. Me, usually, I just leave it like it looks, and I'm going to bring down the y plus 9 times the x. Now, we need to get this y plus 9 by itself over here, the parentheses. So y'all, since they're multiplying by the x, I'm going to divide both sides by that x. That way it's gone. So I'm going to have my y plus 9 times x divided by x. That's going to equal my 5 divided by x. But notice what happens. Those cancel. Now, y'all, if you look at this part right here versus this part right here, where I had the x equals 5 over y plus 9, basically all we did was flip-flop the y plus 9 with the x. The y plus 9 came up, and now the x is on the bottom. At this point, since all we have is a y plus 9, we can drop those parentheses and make that a y plus 9 equals our 5 divided by x. So y'all, I got one more move to get my y all by itself. And that is to come in.
From both sides.
There you go. So notice the y is now by itself on the left side. No, we can't really add or subtract these. They're not what we call fractions with a like denominator. So I'm just going to leave that a 5 over x minus 9. All right, so at this point, we got the y solved for. So let's replace it with our inverse notation. And that'll give me a 5 over x minus 9. So MATLAB just wants this answer to be that function. So y'all, they're not too bad. I'll tell you, this is probably the trickiest one because it's set up as that fraction. Okay. But basically, when you got a fraction like this, you can switch these bottoms and tops right off the bat, because that's all we're doing when we multiply by that y plus 9 and do all that. We're just switching them around, okay? All right, y'all. What's next? Number 10. This one is going to be f of x equals x to the third minus 4. So remember, x to the third, that's in little squiggly graphs. So let's go draw that. So I'm going to go to my calculator, go to y equals, clear that one out. So x to the third, I'm going to hit my x. Under the clear button, you got an upside down v. That's what we call a caret. That does the exponents. So put your 3 in. And y'all, the newer calculators, you actually got an arrow right and bring the cursor back down and then put in your minus 4. All right, so I got my x to the third minus 4. So let's graph it and see if it's 1 to 1. And y'all, that's one of them sort of squiggly lines, but it's going uphill left to right like we drew a while ago. So once again, it is definitely 1 to 1. So I guess they don't want y'all to put no for A and be done. They want y'all to actually find these inverses every time, okay? So y'all, lead me on. What are you doing first?
Y equals x cubed minus 4.
That sounds good. And then next,
Don't you flip the y and x values if I'm not mistaken?
that sounds good. So that's gonna give us what?
X equals Y cubed plus or minus 4.
All right, y'all, now we're gonna solve that for that y. So we haven't solved for a cube yet, so let me show you how we would do that. So your first step would be to get this y cubed by itself.
Add 4 to both sides.
Okay, we're gonna add 4 to both sides. All right, so now I have an x plus 4 equals y cubed. So let me see if y'all can remember a way that I can take a y third and turn that into a y. I don't think we've done that yet this year. So y'all watch this. To undo exponents, we use roots, like square roots and cube roots. So to undo a cube, you would take a cube root of both sides. So a cube root of x plus 4 would equal a cube root of y to the third. These exponents and these cube roots cancel each other out, so that all that's left on that side is a y. So the question is, could you do anything with this cube root of x plus 4?
No.
No.
So y'all, that's just going to stay a cube root x plus 4. We have a y by itself, so now you would just use your inverse notation and put in a cube root x plus 4. And then MATLAB will have a button with a square root looking radical with a little blue box there. You hit that one and then it lets you put in the 3 for that, okay? So to undo exponents, we use roots. Square roots undo x squares, cube roots undo x cubes, and so on. Now, y'all watch this next problem. They're going to restrict my domain. So let me show you what I'm talking about. They're giving us f of x equals 3x squared plus 2. But then they got a comma, and they say that your x's have to be greater than or equal to 0. They're restricting my domain on this one. My x's cannot be negative, it looks like, right? They want all the x's to be positive. So let me show you what they're talking about. When you graph this one, we're going to go to y equals. So first, let's put in the little function they gave us. It was 3x squared. So 3x, and I'm going to hit the x squared over here to square it, and then plus 2. So they told me to restrict my domain, and the smallest x was going to be 0. So when you graph this, actually, I'm going to set my window up. Let me see. I'm going to go to the window button. And you see where it says x minimum is -6. We need to change that x minimum to a 0. Because we don't want to look at the negative x's. We only want to look at 0 and above. So now let's graph it now that we said x had to be greater than 0. Hit graph. So you only see the right side of this graph. But y'all, the question is that right side of the graph 1 to 1?
Yes.
Yes.
Yeah, so they can make a parabola 1 to 1 by restricting that domain, okay? Now, if I wanted to go back to normal, I would hit zoom and 6, which is zoom standard, and it puts it back. So totally it's a parabola, but they restricted our domain, which means we're only looking at the right side. And let me tell you something else they did on that. On this problem, they gave us this much of the answer. They said f negative 1 of x equals the square root of something divided by 3. So they're giving us this much of the answer. All we got to do is really figure out what's going to go into that box. So y'all, let's figure it out. First step, take care of that f of x and replace it with a
Y.
all right, next step.
Switch the y and x variable, my bad.
Oh, you're doing good. So here's the thing. You got a y squared over here. I'm going to solve it like we did this y to the third. But instead of taking a cube root, we'll take a square root, okay? So if we're going to do that, y'all going to have to move that 2. So you're going to have to come in and subtract my 2 from both sides. So I get an x minus 2 equals a 3y squared. So we're close to getting the y squared by itself, but we need a 1 in front instead of a 3. So y'all, that means you're going to have to divide both sides by the 3. So those 3's cancel, making that a 1y squared. Y'all, we can't do nothing with that, right? X minus 2 over 3 is just going to stay at x minus 2 over 3. So here's the final question. Turn that y squared into a y. And that answer is giving you a clue, right? You see a big old radical over that. That's a square root radical. So to turn a y squared into a y, we got to take a square root of both sides. So the square root of a y squared gives you a y. No, we can't do nothing with that. Square root of x minus 2 over 3 is going to stay a square root of x minus 2 over 3. Which looks like we now know what's going in that box, right? There's the 3 on the bottom. There's the square root. So all you would do on your f negative 1 of x is put in an x minus 2 in that box, hit enter, and be done. So just bringing back all those equation memories, right? All right, y'all, so I'm going to try this one, see what y'all do. I'll let y'all do more of this one. F of x is going to equal a square root x minus 3. So let me graph it, and then y'all figure my inverse out. So I'm going to go to my calculator. I'm going to go to y equals and clear that one out. So the square root is on the x2 key. You hit the second button, and then the x squared key that puts up your square root, and put an x minus 3 under it. So x minus 3. And it's real important that it all stays up under that radical, okay? So let's hit graph. So it's a slowly increasing uphill to the right, which means, y'all, this is definitely 1-to-1. So y'all are about to find me an inverse on this one. All right, so your first step.
Set the f of x to y. That's what I tried to say.
Good job. All right, next.
Flip the variables, so x will be where y is, y will be where x is.
All right, y'all, so here's the thing on this one. We cannot move this -3 at the moment because it's stuck up under this radical. And remember, that's not really a 3 when it's under that radical. So you can't just add 3 to both sides because there's no way to add numbers to numbers underneath a radical. So your first move, you got to get rid of that square root. So how can I get rid of a square root?
Would you divide it?
So let me give y'all a clue. Up here we did cube roots, right? Cube roots undone to x cubes. Over here, square roots undone to x squared stuff. So here's the trick on that one. Let me let one in real quick. So y'all must be getting knocked off or something. So radicals and exponents undo each other. So if you want to undo a square root, you're going to square both sides. So you're going to come and square this x, and then you're going to take this square root of y minus 3 and square that. When you square a radical, it cancels that radical, and all you end up with is your y minus 3. X squared you can't do nothing with, so bring that down. So y'all remember that radicals and exponents undo each other, okay? Oh, y'all got one more move on this one.
Add 3 to both sides.
Add 3 to both sides. So let's see, I get what? X squared plus 3 equals my y. So good job. We'll just replace the y with the inverse and get an x squared plus 3. Basically, once you got it to the y equals whatever, MathLab will already give you that. Like I said, all you're putting in is that little answer, okay? So y'all, that was inverse functions. The main thing in there is switching those x and y's around, okay? So we're going to get a start in 3.5 next. All right, so let me flip this paper again. So we'll probably do the 2 variables tonight and then start with the 3 variables on Wednesday night. So this is 3.5 and it's systems of equations. In 3 variables. Now, I'm going to do 2 variables tonight because you got to get good doing the 2 variables before we can do the 3 variables. And I'm going to solve these systems by elimination. So let me show you what we got. We'll have some number x plus some number y equals some number c. And then down here we might have a dx plus a ey equals some number f. So A, B, C, D, E, F just represent numbers. The main thing you got to realize, the x's have to be in order. The y's have to be in order, and then the numbers. You got to be in the form of the ax plus by equals c on these, okay? So this would be what I would call a system of equations in 2 variables. My variables would be the x's and the y's. So steps to solving these. And we're going to solve these using what we call the elimination method. So the first thing I do, I look at my variables. I got my x's and my y's. I try to figure out which variable is the easiest to eliminate. So I'm going to choose a variable to eliminate by adding the two equations together. So I'm going to look up here. Hopefully when I start, I got like a 9x and a negative 9x. Something that'll eliminate really quick. But y'all, if not, it may be needed to change one or both of the equations. And I can change the equations by multiplying everybody in that equation by different numbers. Okay. So I'll show you what I'm talking about on that when we hit one of these. But y'all, after I've eliminated my variable, one of my two variables, I then solve for the remaining variable. Because if you eliminate the x, that means all that's going to be left is a y equals some number. Solve it for that y, okay? So solve for the remaining variable. So if I eliminate the x's and I get a y, once I get that y value, I plug that y value into one of the two equations I started with and solve for the x. So we call that back substituting. So we back substitute to solve for the other variable. So we're going to pick a variable to eliminate, solve for the remaining variable, and then back substitute to get the other variable. Now, we write these answers as an ordered pair, which will be a parentheses with an x value and a y value. And you got to put these in parentheses when you put them in MATLAB, okay? So we use these ordered pairs to represent our solutions. And y'all, just what? Just like any other equation, you can always take your answers, plug it into these equations, and make sure you get a true statement out of that, okay? So they sound tricky, but let's do some of these. So we're going to solve by elimination. So y'all, our first one, we're given 6x plus 9y equals negative 24. Then I got a 2x minus a 9y is going to equal negative 32. So there's my system of equations. So y'all, let's see. Do y'all see a variable that y'all want to eliminate?
Yes, the 9. Well,
No.
the y.
The 9.
Yeah, because if I add these together, positive 9 and negative 9, they're going to give me a big 0 y. So we're going to eliminate that y. We'll eliminate the y by just adding these two rows together. I didn't have to change anything on these. So let's see, 6 and 2, it's going to give us 8 x's. The 9y, negative 9y cancel. And over here, that's a negative something. Let's see, that's what, 56, it looks like. So now you got an 8x equals 56. Solve for the x. Y'all got one more move to solve that for that x.
Divide 8 by both
Divide both
sides.
sides by 8.
So that means x, that's going to give me 1x is now what? 56 divided by 8.
Negative 7.
Negative 7. So we know what the X value is. So now we're going to come over here and back substitute.
On these, can we choose an equation, or do you have to get it back into both equations?
Oh, which one you want me to use, the first equation or the second?
The first one.
Okay, so I'm gonna put that -7 in for the X with the 6. You can pick either one of these two though, okay? You could have done the second one, but I'm like you, I like to avoid these negative variables. And since all these are positive variables, I would probably pick that first one too. So that's gonna give us 6 times -7 plus 9y is going to equal a -24. So I'm going to start out by multiplying that. So what's that? 6 and 7. That's a -42 plus 9y is going to equal -24. All right, y'all, let's solve for the y. We're going to take that 42 and add to both sides. So that cancels. I get a 9y. Oh, what's that? 42 -24. Oh, let me see. I think that's what, a positive
18.
18. Final step, divide by 9. So the 9's canceled, and I get y equals a +2. But remember, your answer has to be in parentheses. And I think you actually got to add those parentheses on these problems. So remember, my X has to go first, which was, where did my X go? Over here, -7. And then the Y value is a 2. Now, I'm going to show you how you can check your answers. I won't do this every time, but if you wanted to check them, take either equation and put your numbers in. And it has to be a true statement. So 6 and -7 will be -42. Plus 9 times 2 is 18. And the right side is -24. Well, y'all guess what? -42 and 18 is a -24 equal to a -24. That's a true statement. So that means our answer was definitely -7 2. So y'all, not too bad. I'm going to do a few of these examples so you get good at this, okay? But we're going to pick a variable to eliminate, then solve for what remains. So y'all ready to try another one?
Yes.
All right, so y'all try this one. We got 11x plus 2y equals a -13. 2x minus a y equals -1. So the question would be, which of these variables looks easiest to eliminate? Because I can't just straight up add them and get rid of anything at the moment. So to me, I'm going to get rid of the y's because you got a positive 2y here. This one's already negative. But what could I multiply the second row by to cancel those y's?
Two.
Yeah, because you got a positive 2y here. If I multiply this whole row by 2, that'll give me -2y there. So we're going to multiply second equation by a 2. So y'all, the first equation stays the same. All right, everybody gets multiplied by that 2. So 2 times 2 is 4x. 2 times -1 is a -2y. 2 times -1 is a -2. But y'all look at that. These y's Now cancel. So let's add up and see what we got left. We got 11x's plus 4x's. We got a negative 13 and a negative 2, which will give us a negative 15. We've eliminated the y. So now solve that for the x. And y'all, the only move I need to do is what? Divide both of these by 15, okay? So 15x divided by 15 will equal negative 15 divided by that 15. So notice, those cancel, giving me a 1x. But y'all watch out over here, negative 15 and a positive 15, unlike signs, is going to make that thing negative 1. So we now know what the x value is. So now we come in and we're going to back substitute. So y'all, which equation would you do? The first one or the second?
The first one.
Okay, so I got 11 times negative 1 plus 2y is going to equal a negative 13. All right, so I'll multiply that first and get what? A negative 11 plus 2y equals negative 13. Y'all got 2 more moves.
Add 11 to both sides.
Okay, so I'm going to add 11. So it looks like I get a 2y. That's what, a negative, that's a negative 2. All right, then my final step.
Divide both sides by 2.
Oh, look at that. My y is the same thing. It's actually a negative 1 like my x. So my answer would be negative 1 for x, negative 1 for y. All right, y'all. So here's the thing. On the next one, I'm going to show you how to do these on your calculator. So I'm gonna do 4 on this one on the calculator. This is actually y'all's number 4. And then I'm gonna go back and let y'all do number 3 on the calculator and see what kind of answers we get, okay? So for this one, I got a 5x plus a 4y equals 62. I got a 4x plus a 5y equals 64. So do y'all all got calculators now? Anyone don't have a calculator? Okay. Because even if you get the phone apps, you can do these problems on that, okay? So y'all got my numbers wrote down. 5x, 4y equals 62, 4x plus 5y equals 64. So I'm going to use what we call the matrix on the TI-84. The matrix will help us solve these problems and get answers pretty quick. The trick is learning how to put these in, okay? So to get the matrix on your calculator, you hit second x negative 1. That brings up your matrix. So since we're putting in a new matrix, when we hit second negative 1 matrix, we arrow over to edit and hit enter. So at that point, let me show you what we got going on. So let me share my calculator. So I'm gonna clear all this stuff and go to my home screen. All righty. So let me clear this side off also. That way y'all can see my key punch on my. So I'm going to hit second, which is the blue button. X negative 1 is the 4th button down the left side. When you hit that, it brings up names, A, B, C, D, whatever, math, and edit. So we're going to arrow right to edit. Once we get to edit, we're going to hit enter. So where I got 3 by 4 on here, that is what the size of this matrix is. It's going to be the number of rows times the number of columns. So on that problem I just did, how many rows?
2.
It's
Mm.
So it's going to be 2 rows. So you would hit 2, enter. And then how many columns?
2.
Oh, think about it. You had your X column,
3.
Y column, and
Three.
then your answer
3.
column. There you go. So that's going to be a 3 and enter. When I do that, look what it does. It makes 6 boxes for my numbers. Now, we don't put the variables in here. We're only going to put the numbers. So for 5X, I would hit a 5 and enter. So see, it put a 5 in the first spot. I had 4Y, so that would be 4 enter. I had 62, so that would be 62 and enter. So you got to hit enter after every number we're putting in. Now look, it went to the second row. I had 4 X's, so I would do a 4 enter. I had 5 Y's, so that would be 5 enter. And then I had 64, so that would be 64 and enter. So now 5X plus 4Y is 62, 4X plus 5Y is 64. We now have the matrix in there, right? So at that point, let me go back and we'll write what we got going on. All right, so we put enter, and right here we had to put our rows times our columns, and then we entered the numbers. At that point, you hit second mode because we want to quit that screen. So let's go to my calculator and hit second mode to quit that screen. So second mode, that does the quit. Because now the calculator knows what that matrix is. It knows it's a 2 by 3. It knows what numbers we need. So y'all, the next thing we do, I'm going to write these steps down for you. So for the second time, we're going to go to second X -1 for the matrix. But this time we're not going to edit. We're going to arrow right and go to math. Once we highlight math, we're going to arrow down and get RREF. This stands for reduced row eliminated form. So this will give us all of our final answers. So let's go do that.
Did you say REF?
We want RREF, so go one more. So you got second math, second X -1, arrow over to math, and then scroll down because you already had both of those in there. A REF and then a RREF. So here's the difference. If you do the REF only, it'll give you the last variable, but then you got to back substitute to get the other ones. If we do the RREF and hit enter on that, this one will solve it all the way down. So you should have RREF setting on your screen. Guess what? Now we got to go get the matrix we just made. And to get that matrix we just made, we hit second X -1 for the third time. And notice A says that's my 2 by 3 matrix. And I always keep them on A anyway, because it's always highlighted. So since A is the matrix I want, I'm just going to hit enter. Whoops, hit enter. And now it brings it on the screen. So we're going to reduce this system of equations that we just put into this calculator by hitting enter. Now on the right side, you see a 6 and an 8. They're going in alphabetical order from the top. So the X would be the 6, the Y value would be the 8. And we're done. So y'all like that?
Yes, it just has a lot of steps, but I like it.
It's got a, but once you learn, it's mainly doing that second X negative 1 every time. Once you remember that, it saves you from, because if we were solving this thing by hand, anyone want me to solve it by hand to show you how much fun it is?
Yes. No.
Okay. So let me get my paper rolled flipped over here. And then we'll see which way y'all like. So I got a 5x plus 4y equals 62. And then a 4x plus 5y equaled 64. Well, y'all, pick me a variable to solve. You want to eliminate the x's or the y's. And you know what's funny? Yeah, they look the same, don't they? I got a 5 and a 4 over here on my x's. I got a 4 and a 5 on the y's. So y'all just pick one of them out. Which one you want me to eliminate?
Y's.
So to eliminate the y, I got to make one of these positive, one of these negative. So here's the question. I can't do nothing with a 5 to turn it into a 4. I can't do nothing with a 4 to turn it into a 5. So you're going to have to figure out what the smallest number 4 and 5 both go into.
20.
It's 20. So I need to make one of these a positive 20 and one of these a negative 20. So I'm going to keep the top positive. To make that a 20, I'm going to multiply this whole row by a 5. So watch what that does. That's going to give me 25 x's, 20y, and woo, let's see, what is 62 times 5? That's going to be what, 310, I think?
Yeah.
Okay, so I multiply that by 5. This row needs to be negative. So since I got a 5 there, I'm going to multiply that row by a negative 4. So that's going to give me a negative 16x, a negative 20y, and whoo, what's that? 64 times 4, y'all? 256 negative. I think that's negative 256. So notice, in extreme cases, you got to change both rows to get rid of one of them variables, okay? So let's add this up. 25 and negative 16 gives me 9 x's. The y's cancel. And y'all, let's see, what's 310 minus 256?
54.
Positive 54. That looks good. All right, y'all. Now we're going to solve for our y. I mean, solve for the x. Divide both them by 9. So I get an x is a positive 6. Well, guess what that matrix gave me, Walgo? From my x value, it gave us a 6. So now I'm going to back substitute. All right, so y'all want me to use the 5x plus 4y equals 62 or the 4x plus 5y equals 64?
It don't matter.
Yeah, they're both pretty easy. So let me just try that top one. 5 times my x of 6 plus 4y equals 62. What's that? 30 plus 4y equals 62. And then it's just solving that for that y. So let's see. Let's subtract 30. So 4y is now, what's that? 32. Oh, this is gonna come out what we needed. Divide by 4. And y'all guess what? 32 divided by 4 gives us that 8. So either way you go, you're going to get a 6,8 for that answer, okay?
Can I see your page that had the steps listed out again real quick?
That had the what on it?
The calculator steps.
So it should be this one. And then once I brought the REF on and hit enter, I then hit second x -1 for the matrix. And then I just hit enter to bring that to the screen. And then once you got the REF and your matrix on the screen, hit enter and be done. So I'm going to do one more with these 2 variable equations. And that means Wednesday we'll do these with 3 variables, okay? And y'all really going to love those. Oh, did you get my stamps? I'm going to give you a little more time.
Yeah, I just took a picture of it.
Oh, okay. No, y'all, so let's see what I'm going to have in. All right, so this one's really number 3 that I'm calling number 4. 8x minus 9y equals 16.5. 7y minus 2x equals a negative 6.5. So here's the question I'm going to ask y'all. What should be my first step?
You need to flip your X and Y.
Yeah, the second one's out of order. Ooh, good job. So we need to put them in order. So you really have a negative 2x plus a 7y equals a negative 6.5. At that point, if you wanted, you could put this right here into your calculator. But y'all, I'm going to solve it by hand. How about that? And then we'll solve it by hand. Then I'll go through the steps on the calculator one more time. So what I need to know from y'all, what are we eliminating? And y'all, please pick the easy one for me.
It's the X.
Okay. Because the Y, 9 and 7, that'd be like what, 63 for the smallest number they both went into? Because I got an 8x here and a negative 2x here. What will you do to make them eliminate?
Multiply the bottom by 4.
Oh, good job. I like that. So the top row stays the same. 8x minus 9y will equal 16.5. Let's see what this gives us. That's going to give us negative 8x like we needed. 28y. And then y'all, what's that? Negative 6.5 times 4.
Is it negative 20?
Should be negative what, 26?
Yes.
Okay. And y'all, that's a good job because look at these x's are gone. 28 and negative 9 give me a 19y. And then let me see what I got here. 16.5. Negative 26. Are y'all getting a negative 9.5? All right. So now divide by 19 and let's get the y value.
Y equals negative 9.5 over 19.
So what are y'all getting?
I did it wrong, but I got
I got a
negative
0.5.
0.5.
I'm
Yeah.
getting the negative 0.5.
Oh,
I think you went the other way, okay. All right, so we know the Y value, so now we get to back substitute. And I guess it don't matter on this one. Oh, I can use either of those two equations.
okay.
I think I'm just going to get this negative and make this all positive. So I got an 8x minus 9 times a negative 0.5 equals 16.5. To bring down the 8x, so y'all, we got to figure out what is negative 9 times a negative 0.5.
Is it 4.5?
I'm getting a 4.5. So 8x plus 4.5 equals 16.5. All right, let's subtract 4.5. I'm now going to have my 8x equals, is that 12? 1650 minus 450, that'd be $12, right? So that'd be 12.0. And then what? Divide both sides by that 8.
Would it be 1.5?
Sounds good to me. So your value, your answer would be 1.5 for the X and a negative 0.5 for your Y. So y'all, let me go through on that one more time and show you on the calculator. But remember, on the calculator, we got to have the order done right. So I'm going to put in the 8x, negative 9y, 16.5, negative 2x, 7y, negative 6.5. So let's run that one on that calculator. All right, so I'm going to clear my old screen off. All righty, so remember.
Can somebody mute their mic?
Yeah, I'm seeing, let me try, I think that might have been it right there. All right, so second, x negative 1. Go to edit, because we're going to put in our matrix. You know, edit, hit enter. So it's already a 2x3, but you got to hit enter on it. So enter on the 2, enter on the 3. All right, so we had 8x, so that'll be an 8. Enter. Minus 9y, so that'll be a negative 9. Enter. Gave me 16.5. And enter, it's going to go to the next row. I had a negative 2x, so that's negative 2. Enter. 7y, so 7, enter. And then it was a negative 6.5. And enter. So I've entered all my numbers. Now I'm going to quit that screen, member, by hitting second mode. So anything that's in blue, that's why we're hitting the second key to get them blue features. Now, I'm going to go back to second x negative 1 for my matrix. I'm going to go to math by arrowing over once to the right. And then I'm going to go down and get RREF and bring it to my screen. So I'm on RREF, I'm going to hit enter. In my last step, member, go back and get that matrix by hitting second x negative 1 again.
Can you redo that step again? What do I hit? Okay,
So
so
clear this off. So we done got a matrix in, right?
right.
Okay, so we're going to go to second x negative 1 for the matrix stuff. But we don't want to edit the matrix now. We want to do some math on it. So arrow right until you hit math. And then go down till you find RREF. It's B on mine.
Thank you.
Hit enter on that. That brings it on the screen. And then go get that matrix by hitting second x negative 1. So you got to hit second x negative 1 3 times on this. But guess what? Matrix A is highlighted. It's that 2 by 3 we just made. So I hit enter. There's my RREF. Now remember on this one, we got what? 1.5 and a negative 0.5. So let's hit enter and see what we get. So y'all look at that. That top number is my X, 1.5. Under it, you see a negative 0.5. So no matter which way you like doing these, I'll take them either way. Either get good by hand like we're doing. I mean, because these are sort of fun to do if you get the right answer. Or learn that calculator, okay? I will say this. When we hit the 3 variables, those are going to take a little bit more time to work. If I was in a classroom, I could probably take up a whole board doing a 3 by 3, a 3 by 4 system, okay? So Wednesday, I'll do a few by hand and then I'll show you how to do them. Pretty much the same way on the calculator as these were, except when you go in, they're 3 by 4s and then you put in 12 numbers versus, what are we putting in 6? So it almost doubles the size of them. But it'll give you the answers on the right side for your X, your Y, and your Z, okay? All right, y'all, so here's a question. Any questions on this tonight? So to stay caught up with me, do your 9.2, which was your inverse functions, and maybe do the first 4 or so on this homework. The first 4 went over the 2 variable equations like we just did. Wednesday, we'll finish up 3.5 and we'll knock out 3.7. 3.7 is not that long. 3.5 will take most of your time this week, okay?
Okay, I have a question. This is off topic,
Uh-huh.
but when we get close to the test, will we have like a review little thing, or will we just
So
test?
what we'll do, we'll finish out everything for test 1 by by Wednesday night. Next Monday, when we come in, all we're doing is reviewing for test 1.
Okay.
And then Wednesday, I'll start the new material for test 2, doing that 7.1 and 7.2. But usually those are sort of light so that we don't overburden you that week. So I will do a version of the study guide. And y'all make sure before you do this test 1, you definitely want to do that study review guide. It counts as a quiz grade, but it's the same 20 questions that's going to be on my test. And you can take the review quiz as many times as you need. You only get 1 shot at the test. So go through that review quiz, get good scores on it, then I would attempt that test, okay? Because you can do the review quiz as many times as you want. All right, y'all.
Did you say they're the same questions?
Well,
Where you wanna-
it'll be the same 20 questions, same order, but they'll change them numbers up.
Okay.
Okay, so they might give you y equals 2x plus 5 on that, but my test might be y equals 4x plus 5 or something. And here's the thing I've seen also. People that do the review quiz more than once, say you do it 2 or 3 times, it's very possible that some of them questions will be the same exact questions on your test, because it only regenerates so many versions of each question, okay? So if you went through that review quiz once, it's possible out of them 20, you might get a repeat of that question on that test. That's just how them little test generators do stuff. But yeah, either way. All right, so what y'all want to do, 9.2, play with your calculator a little bit if you want to for 3.5. Y'all was helping me pretty good on them 2 variable equations and doing good. So either way, y'all should be fine on those, okay? All righty, y'all, so that's all I got, so I'm gonna stop recording this main lecture.